Hello, hello. I hope everyone had a good lunch break. And we're back with Wolfgang Ofner, who's going to tell us about how to run multi cloud environments with the help of the native Azure tools. Wolfgang, over to you.
Yeah, thank you. Welcome to my session, Unleashing the Potential of Hybrid Cloud, Streamlining Multi-Cloud Management and On-Premise Integration. I know the title is quite a mouthful, but I hope at the end of my session you will know what hybrid cloud is and what advantages it brings. Before we start, just a couple sentences about myself. My name is Wolfgang Ofner. I'm a freelance cloud architect. I'm based in Toronto, Canada, and I focus on Azure, and there mostly on Kubernetes, DevOps, but I also have a .NET background, so I can also help with programming. If you want to get in touch with me, you can find me on my website, on LinkedIn, and also on my YouTube channel. And today I want to talk about first what hybrid cloud is. Then I'm going to talk about how we can use Azure Arc and Kubernetes to implement hybrid cloud. Then I'm also going to show you how the integration works. Then I'm going to talk about 2 real-world projects I was involved with, and then I give you my opinion of hybrid cloud and the whole Azure process. So let's get started with hybrid cloud. First off, the definition. It's one of the definitions I found on the internet. So hybrid cloud is a combination of public and private cloud services along with on-premise infrastructure, creating a unified computing environment that offers great flexibility, scalability, and cost effectiveness. So the idea of hybrid cloud is that you mix your on-premise infrastructure with the cloud and hopefully use the advantages of both environments. So the types of hybrid cloud, there are 3 types in my opinion, although the first one is not really hybrid cloud. So the first one I was thinking about is what I see often is with companies that they split the on-premise and the cloud environment. For example, they already have an on-premise infrastructure, so they run the old software there, but every new software will be deployed on the cloud, and there's no link between them. So I wouldn't really call it hybrid cloud. The next one is when you already use on-premise, but you extend it to the cloud. This could be, for example, for simple services. So your on-premise application uses a storage account or a database in the cloud. And also what's often done is a connection between on-premise and the cloud using a VPN connection or an express route. Express route is a private connection from your on-premise data center to the cloud. And this allows you to have a low latency connection. And as said, a private connection, you don't have to encrypt the data because it doesn't go out to the internet. And the last one, which is a real hybrid cloud connection, is that you connect them or you combine them. For example, you could have your on-premise infrastructure, but you run cloud services in your own data center. And I'm going to explain later to you how this could work. So now to the benefits of the cloud. The first one, which is a big one, is the data sovereignty. Many companies have very sensitive data. This could be customer data, health data, or just like secrets they don't want any other competitors to know. So if you use a hybrid cloud, all the data can stay on your own premise infrastructure, so it never leaves your premise, and you can make sure that it stays safe. The next thing is security. If I have full control over it, I don't give my data, especially out to like Microsoft or any other cloud provider. I can make sure it's secure, and I also have full control about the infrastructure. So I can make sure nobody has access to it, and I can implement whatever I need for the security. The third one, latency. Obviously, if I run the data on-premise, there's the lowest latency possible. This is useful if you need data processing right in your data center or on-premise. For example, I work with factories. They produce something, for example, a cable or a part for a car, and then they want to instantly check the quality. So they use cameras to check the part produced, and this needs a low latency. Sending this out to the internet, waiting for a response might be too slow because they produce so much and so fast that every millisecond counts. Then obviously the cost. Cost is always a big factor. Here I'm thinking about, I already have infrastructure and I just use cloud services on this infrastructure. So I don't have to pay the full cloud services. I run my own hardware and therefore can lower the costs. And lastly, the resiliency. This is also with my customers, they're in factories that are in rural areas, in less developed areas, and it happens that the internet connection is gone for a couple hours. So if I only use cloud services, I can't do anything in this time. And this could cost like hundreds of thousands or even millions of euros. And if I run the application on-premise, maybe not the full application, but enough to keep running, I can just keep producing. And once the internet is back, I just connect to the cloud again. Then obviously, with every solution, there are some downsides or challenges. So the first thing that comes to mind is the complex infrastructure, because I don't only have to use a cloud service or an on-premise infrastructure. I have to combine them. But this also means I have routing in between, I have networking, firewalls, DNS. So it gets quite quickly quite complicated. Then also security and compliance. I said security could be an advantage if I only run on-premise, but it can also be a disadvantage or at least a challenge because I have to manage a combination of both worlds. So I have to make sure it's secure on-premise. I have to make sure it's secure in the cloud and also in between. And the same with the compliance. I have to make sure if I'm compliant, especially if I'm, for example, a health provider, that's very strict. And if I have more environments, it's going to be more of a challenge. The third one, data integration. This is a bit of a processual problem. What I'm thinking about here is if I have on-premise data, I have cloud data, and I just copy the data around, I have to make sure that I know where the data resides, where it's processed, and that it's encrypted and secure. And the last one, which is maybe even the biggest one, is the skill set of my teams. So traditionally, if I have on-premise infrastructure, I have a couple IT administrator. They know how to set up everything, how to manage everything. The same if I have the cloud, I have a couple cloud IT administrators. They know everything. But combining them can be a bit of a challenge because often the cloud guy knows cloud stuff, the on-premise guy knows on-premise stuff, but they usually don't know both. So it's quite a learning curve for the team. And now how we can run this service on-premise. First off, Microsoft offers a couple hardware solutions. They're called Azure Stack Edge, Azure Stack Hub, and Azure Stack HCI. So the Azure Stack Edge allows you to run Azure services in edge environments. That's usually small devices that are in plants or in like rural areas where you don't need much processing power. Then with the Azure Stack Hub, this allows you to run Azure services on your on-premise environment. And it's almost as having your own Azure environment. The only downside is that it doesn't offer all the services. And what I want to talk about today is the Azure Stack HCI. So HCI stands for Hyper-Converged Infrastructure. And this allows you to have a real hybrid environment. And all of this is managed with Azure Arc. Azure Arc is a software solution, and this can be combined to create the hybrid environment. So first off, the Azure Stack HCI, it's running its own operating system. It's very creatively named Azure Stack HCI operating system. And it's based on the Windows Server operating system, just with less features. But it also has some features that are used in previous versions of Windows Server, but also in the cloud. For example, Hyper-V, so you can create virtual machines. We have storage spaces direct, which allows us to create storage efficiently. And we have software-defined networking, the same as we have in Azure. And additionally, we can build clusters with Azure Stack HCI. So we can have clusters between 1 and 16 physical servers. This could mean, for example, in our headquarters, where most of our employees are, we need more resources. So we could have, for example, 8 physical servers. But in our branch offices, where we only have a handful of employees, we only need 1 physical server. And so we can set up the server according to the needs we have. And they're also often used in disconnected scenarios. This means, for example, on planes or on cruise ships. So the planes and the ships have access to the internet when they're in the harbor or the airport. So the software developers can install new updates, some patches, see what's going on. And once their plane is in the air or the cruise ship is on the ocean, they lose the connection to the internet, but the software still continues running. And so our customers can continue using the entertainment system, payment systems, and everything I have. And it's a great experience for the customers. And here you can see how everything works. So on the bottom, so on this layer, we have some hardware. Then we install the operating system. And then we can use different services. So for example, here on the left, we have virtual machines. We can use Windows and Linux, doesn't matter. Then we can also use Azure Virtual Desktop. So that's the same as in the cloud. I think I just lost my, presentation. So now we should back. So now it should work again. Then we can have Azure Virtual Desktop. That's the same as in the cloud. And we also can use Azure Kubernetes service. And this means we can run a managed Kubernetes service on-premise. And all of this is managed with Azure Arc. I'm going to talk on the next slides what Azure Arc is. And additionally, we can have more services that we are using already with Azure. For example, the Azure Key Vault, Azure Monitor, Azure Backups, and all this is integrated in the software. And here we have an overview. If you have to decide what hybrid cloud solution you want to use. That's provided by Microsoft, and I don't want to talk too much about the details. I just want to have this out here so you know that it exists. For example, if you use a multi-cloud, this means you're using Azure and GCP, AWS, Alibaba Cloud, you go with this branch. And if you're using Azure, you would start out here, and then you decide what you want. For example, if you have hyper-converged, as I said, with Azure Stack HCI, you will add up down here with Azure Stack HCI. And this helps you decide what solution is the best or might be the best, and then you can look into it. Then the second slide I have here is, again, just an overview of what you have. And first off, we have here the Azure Cloud, and obviously that's running the Azure Data Center, and everything is running on-premise. And what's interesting is here that everything can be managed with Azure. No matter where it's running, it's integrating with Azure. So you can use the portal, but you can also use the management tools you already used running in the cloud. And again, I just want to talk too much about the details. That's just out here, so you've heard about it. And if you're more interested, you can take a look at it. And now let's talk about Azure Arc. Azure Arc is an awesome tool by Microsoft, and it allows you to project your infrastructure that's running outside of Azure. This means it can run on a different cloud like GCP or AWS, or on-premise, it doesn't matter, inside of Azure. This means you can see it in the Azure portal, and you can manage it as if it was running in Azure. And you can manage with this Linux and Windows VMs, and also bare metal server. You can manage any Cloud Native Computing Foundation certified Kubernetes distribution. So that's almost all of the popular ones. And you can also manage your Microsoft SQL Server. And if you go to the Azure portal, we see here our Azure Arc instance. And on the left side here, we can see all the services we can manage. So on top, with Azure Stack HCI, what we talked about, Kubernetes cluster, some VMware, Microsoft SQL Server. And down here, we can also see we can manage Azure services with it. And I'm going to talk about this at the end of my presentation, but this shows that we can run Azure services on our own infrastructure. And the advantage of this approach is that we can use the same tool we are using if our hardware is running on Azure. So we don't have to learn any new tools. We can just use the same and manage them the same way. So especially for VMs, this could be the update management. This means I can say install Windows or Linux system updates on Tuesday at 2 a.m. and they're going to be installed on the Azure VMs, but also on my on-premise infrastructure. The same with the configuration management. I can configure all the VMs the same way, and I could also run Azure services like the Microsoft Cloud Defender. And as I said, we can also manage our Kubernetes cluster with Azure Arc, and this category is so-called Azure Arc enabled Kubernetes. And this allows us to see the Kubernetes cluster in the Azure portal, but also bring Azure features to the Kubernetes cluster. And this is done via extensions. There's quite a lot of extensions, for example, for Azure Monitor, for GitOps, Azure Policy, Azure Key Vault integration. And today I want to talk about all of them except the Azure Policy. And another also feature which I've used in the past is that Azure Arc allows you to connect to the cluster, even though if it's behind a firewall that's blocking every connection that's incoming into the network. The way it does this, Azure Arc installs an agent, and the agent is running inside the cluster, and then the cluster connects to Azure. And therefore, the connection is from inside the cluster going outwards and not the other way. Now, before we can get started with Azure Arc, we have to have a couple prerequisites fulfilled. So the first one is we have to install the Azure CLI, and then we have to install the Azure Arc extension. This can be done with a single command. So it's just a curl to install the Azure CLI if you're on a Linux, and then the AC extension add to the extension. If you're on Windows or Mac, you'll find the documentation, but it's also usually a single line command. Then we have to register a couple Azure provider. This provider allows us to use certain REST APIs, especially the REST APIs we're going to use for the Azure Arc integration. And that's going to be the Microsoft Kubernetes configuration, and Microsoft Extended Location APIs. And after you did this, you only have to do this once in your tenant. You can use the AC provider show command, and then just what name you want to show. And at the end, I use the -o, that's for output, and table to just display it nicely. And you can see here, all three are registered. This means you can continue. If they're not registered, you have to wait a bit longer. It takes about 10 to 15 minutes to register them. So once we have set this up, we can start installing Azure Arc. And to do this, we use the Azure CLI. So we use the AC connected Kubernetes connect command. Then we provide a name. So that's the name of our Azure Arc instance, and in what namespace we want it to be running. And this is also using the same location as the resource group is running in. If you are using a resource group in a location that's not supported, you will get an error message, and then you can just add the location as a parameter. And this works because I'm connected to my Kubernetes cluster. So what this command does, it also reads the kubeconfig file, so it knows to which Kubernetes cluster you're connected to and executes the command in this cluster. And this installs all the Azure Arc agents. It's around 10 to 12, I don't know the exact number, of applications, but they're all running in the Azure Arc namespace. So you can easily see what applications have been installed. And here you can see them. And also you can see that I'm now using Windows. Before I was using Ubuntu. It doesn't matter. It's just Kubernetes. We need the kubectl, the Kubernetes CLI, and then we can access it. And I don't want to go too much into detail because we don't have too much time today. But if you look at the names, you can already figure out what's going on. So for example, if here some extension applications, they're probably going to manage our extensions. Then here we have cluster identity, a cluster connect, and some metrics. So just by looking at the names, it's already more or less obvious what these applications are doing. So now back to the Azure portal. As I said, we can manage our infrastructure that's running outside of Azure. And the big advantage is that we have a so-called single pane of glass. This means we have one dashboard or one application where you can see all our infrastructure. For example, if our company is using Azure, GCP, and on-premise, usually they would have to use at least 3 dashboards, one for each environment. But this also means Azure has different tools than GCP and probably different tools than on-premise. So it's quite complicated for administrator to learn all of these tools. And with Azure Arc, we just use our Azure tools. So if we go back to the Azure Arc instance, we're going to click here on our Kubernetes cluster. And then we can see all the Kubernetes cluster we are connected with. So the first one here is Azure Kubernetes Service Cluster. And I can see, for example, what Kubernetes version is running on. And here I have an on-premise K3S cluster. And I can also see what Kubernetes version I'm running on. And it's the same overview or dashboard, no matter where they're running. And if I click on one of these Kubernetes clusters, for example, the K3S one, I can see here the same menu as if I was running the Azure Kubernetes service. So I don't have to use or learn a new menu, get to use new features. The only difference you can see is here, it's not Kubernetes or Azure Kubernetes service, it's Kubernetes Azure Arc. And for example, if I want to access the resources, I don't see them straight away. I have to provide an access token. That's just an additional security feature. And it's out of scope for today, but what would you do is create a token inside your cluster and then use this token to authorize the portal to access the cluster. So now let's take a look at the Azure Arc extensions. And with the Azure Arc extensions, you can bring Azure services to your Kubernetes cluster and have already existing Azure functionality running in your on-premise cluster, and also don't have to care much about the installation process. Usually it's just a single line command, and then Azure will take care of the rest. So what you're going to take a look at now is the GitOps extension, so we can manage our deployments, the Azure Monitor for monitoring and alerting, and the Azure Key Vault extension to have a link between our Kubernetes cluster and the Azure Key Vault. So the first extension for GitOps, this extension is using the Flux operator. That's one of 2 popular open source GitOps agents. The second one would be Argo CD, and it can be installed via the Azure CLI or the Azure portal. I prefer the Azure CLI because it's just a single line command and it's very clear what the command does. But before we can install it, we also have to take a look at the structure of our repositories, because usually we have one application repository, then we implement our features there, and once we are ready, we deploy our main or master branch from this repository. With GitOps, Microsoft recommends that we have two repositories, one for the application and one for the configuration. And this is recommended because of the separation of concern principle. So the idea behind this is that developers take care of the application, and then I could have some infrastructure team member that take care of the configuration of the Kubernetes cluster. This could be YAML files, Helm charts, or whatever you need to run your software. And here we can see how this whole process works. So if I implement a feature, I create a pull request, and this hopefully triggers a pull request pipeline. This means my pull request is running through a separate pipeline that's doing some unit testing, maybe deploying the application to test if everything is running. And once that's approved, it's being merged to the application repository. And this usually triggers the CI pipeline. This pipeline runs more unit tests, but also creates the container image and pushes the container image to the container registry. So in this case, it's the Azure Container Registry, but you can use any container registry you want, for example, Docker Hub. And this either automatically triggers the CD pipeline, or sometimes it's done manually. But once the CD pipeline runs, it's updating the configuration. This could be, in the simplest case, for example, update the version number and then commit these changes to the GitOps repository. And then we have over here inside the Kubernetes cluster our Flux, I'm not sure, agent. And this agent sees that there are changes in the repository. So this agent is always monitoring the GitOps repository. And since you just committed something new, the Flux agent downloads these changes and then applies them to the Kubernetes cluster. And with this approach, we implemented a fully automated deployment process without having any access to the Kubernetes cluster, because the cluster is pulling the changes and we don't have to push them. So as I said, installing the GitOps extension is a single line command in the Azure CLI. So let's take a look at this command. So it's the Azure CLI command. The structure is always the same. It's AC, then the resource you want to use. In this case, it's K8s configuration Flux, and then what you want to do. In this case, we want to do a create. And then the parameter are hopefully quite self-explanatory. So we provide the cluster name, the resource group it is in, name for the GitOps deployment, a namespace, then the cluster type. In this case, we use a connected cluster because for this demo, I'm using an Azure Kubernetes service cluster. So if you want to try it out yourself, you can just copy this command. If you use an on-premise, for example, the K3s cluster, you would have to use, I think it's managed clusters. Then the scope, we say that our GitOps extension can install applications in the whole cluster. And then we have to configure the access to the Git repository. So in this case, I have my username and a personal access token. So that's the same approach for Azure DevOps or GitHub. Then the URL to my Azure DevOps server, what branch I'm using. So I'm using the master branch. And then the path to the customization file. The GitOps extension is using Customize. That's just another open source tool. And I'm going to take a look at this in a couple slides. All you have to know for now is with this customization, you can also create dependencies between your applications or between the deployments. For example, you could say, deploy a namespace first, and once the namespace inside the Kubernetes cluster is deployed, then deploy my application. And as you can see down here, it says the extension wasn't found, so it's going to install the extension automatically the first time you execute this command. This is going to take a couple minutes, and then you will see it in the Azure portal. So if you go back to the Azure portal, to our Kubernetes Azure Arc instance, and scroll down a bit and have on the left side here the GitOps section, we can see here our GitOps operator, the one we just installed, and everything is green. So that's great, but not always everything works. So you have to analyze what's going on. And what you can do is you can click on this configuration, and this will give you more information about what's going on. And it will also display some error messages in case there are any. And then if you wait a couple more minutes, we can see our application is running inside the Kubernetes cluster without us doing anything. It's the GitOps operator pulled, in this case, a Helm chart, applied the Helm chart, and the application is running now in the cluster. And now let's have a look at the GitOps repository. So as I said, the Azure Arc GitOps extension is using Customize, and it's using, in the simplest way, a customized file that's just referencing all the release files. Since we don't have too much time today, I want to keep it as simple as possible. So I just have a customized file. You can see here, it's of type customization, and it's referencing one YAML file. This YAML file is called Helm release. And this Helm release YAML file is just containing all the information about our Helm chart. And we can use this YAML file to configure the Helm chart too. So this would be to override the values.yaml file the Helm chart is using. So if you take a look at this file, we can see here it's of type Helm release. Then we just have some information, for example, the name. Then if you use Azure Kubernetes service, you have to provide this label or this annotation, otherwise it's not working. And then with the spec section, we can configure the Helm chart. For example, you can say, check every minute if there are any changes, what's the path to our Helm chart, but we can even configure more, for example, the replicas, or I can add some environment variables. But to keep it as simple as possible, that's all you need for your application to be running. And the last piece of it is to have a GitOps pipeline. And in the project I was working on, we had a pipeline that was reading the newest tag from the Azure Container Registry. So we just did this by filtering by date. Then we replaced the tag we just read in the values.yaml file in the Helm chart. And then we committed this change to the master branch. Then the Flux operator saw these changes, pulled them to the cluster, and applied them. And so we had the newest version running in our application. And another feature, what I think all CD tools, at least GitLab, GitHub, Azure DevOps provide, is that developers can also set parameter when they start the pipeline. So we use this to set the tag. So if a developer wanted to deploy a specific version, they could set the tag when they start the pipeline. And if they didn't set a tag, then we read the newest one. So you are totally flexible to do whatever you need to do for your application. Then the next extension is the Azure Key Vault Secrets Provider extension. And the idea behind this is the Azure Key Vault is a great tool to manage your secrets, your certificates, so everything that should stay hidden or secure. You have auditing, you have automatic secret rotation, you have alerts, access control. And so why not use all of this? And with this extension, you can mount the secrets from the Azure Key Vault automatically inside your Kubernetes cluster. And all of this is done via gRPC. And here you can see how it works. So in the front, we have, so basically all of this is Kubernetes. So it's just creating a new pod attaching the secret store driver and the provider. And then all this extension does is configure this secret store provider to use the Azure Key Vault. And this means that our software developers don't have to change anything in the application. They don't even have to know, in theory, that we're using the Azure Key Vault. They just deploy the application and Kubernetes takes care from where the secrets are coming. So here we have it a bit more detailed. So everything starts with the Kubernetes API server. This tells the kubelet on the worker node to schedule a new pod. And when the kubelet tries to start a new pod, it's telling the secret store CSI driver to create a new mount. So this driver creates a temporary file system volume and mounts it to the pod. And then it also tells the secret store provider to get all the secrets. And we configured this provider to use Azure Key Vault. So we take a look here at our Azure Key Vault, download all the secrets, and then give them here to the secret store driver. And the secret store driver then writes them to the temporary file system and attach this to the pod. But for example, in .NET, we use environment variables to configure our applications, so we can also attach them as environment variables. And this allows us, as said before, that the developers don't have to change the application. We just attach the environment variables. .NET by default reads them and then can use them to run the application. And the last extension is the Azure Monitor extension. So by now we have the deployments, we have the secrets, and now you want to know what's going on in our cluster and also with our applications. So we use Azure Monitor because we also use this in the cloud. And the Azure Monitor extension installs the Azure Monitor agent in its own namespace, so it's separated from everything else. And once the agent is installed, it starts collecting log and metric information and then sends this information to a log analytics workspace. And once we have it in the log analytics workspace, we can use the same tools we are using as if our software is running in the cloud. So for example, for Azure Monitor, we have built-in dashboards, or we can use our own dashboards. We have alerting, and we have also insights inside the cluster and insights into the pods or container. And here you can see the dashboards. They're already built in, so I didn't have to do anything. I just installed the extension and the dashboards were there. And if you take a look at this, zoom in at around 9:30 a.m. Suddenly there was a big spike in CPU usage. So we went from around 10% to 70% and then even higher, above 80%. And with Azure Monitor, you often have alerts if your CPU usage goes above 80%. So in this case, at around, I would say 9:33, the support team was alerted that the CPU usage is really high. And then you can see over the next 2-3 minutes, it increased even further. So here we are at the peak at maybe 90%. But then the support team got to work, resolved the problem, and the CPU usage went back down within like 5 minutes. And our customers didn't see anything that it slowed down, that we had errors, failures. So everything was fine before it became a problem. And there are also some other dashboards, for example, right here with the memory usage. So it's between like 18 and not even 20%. Everything is fine. We can see the nodes, how many nodes we have, and how many pods we have running. But you can also take a look at our containers itself. So as you can see here on the right, the container with the name custom API barely had any resource usage, and suddenly it spiked to 100% and it went red. And what's interesting is if you take a look down here, we have a container that's MQTT. So that's our messaging service. And this already had quite a spike a couple minutes before the custom API went into the red. So this could be a hint that maybe we had a lot of messages and then the custom API was trying to process these messages and just ran out of resources. And this will help us to identify what the problem is. And this again is everything out of the box. So I didn't have to do anything, just install the Azure Monitor agent. And the last thing, maybe even the most interesting one, is run Azure services with Azure Arc on our on-premise infrastructure. So before we do this, there are a couple, I would call it categories of Azure Arc. So the first one is Azure Arc enabled infrastructure. This allows us to manage our on-premise infrastructure. This could be server, Kubernetes cluster, Azure Stack HCI, Microsoft SQL database. And then the more interesting one is we can run on-premise our Azure services. So this is the first time and the only way to run Azure services like the Azure App Service, logic apps, API management, or container apps on-premise. And we can also run so-called Azure Arc enabled data services. This means we can run Azure SQL managed instance or Azure machine learning also in our on-premise data center. And this means we don't have to give our data to Microsoft. We can just run it on-premise and use Azure services and don't have to take care of a database or machine learning. And everything is done with a Kubernetes cluster. So we have a Kubernetes cluster, we install Azure Arc. And once we have the Azure Arc connection, we can run the Azure services on-premise. And the great thing is the developers don't care where the software is running. They can use the same tools no matter if it's running on Azure or on-premise. And here you have an overview of what I just said. So it doesn't matter if you're using one of the many cloud providers, if you use on-premise infrastructure or some edge device, you just install Azure Arc. So that's the centerpiece. And once you have this, you can use Azure services on it. And we are about to run out of time. So I just quickly want to tell you about two projects I was working on that used Azure Arc and hybrid cloud infrastructure. So the first one is called Autonomous Roadway System. There I was involved in a proof of concept. And the second project I'm working on right now is for a smart machine factory. So here you can have a roadway vehicle. So in Switzerland, we use this literally everywhere, in summer for for hiking, in winter for skiing. And the idea of this project is to automate this. So we want to make it intelligent, basically to cut costs, cut wear and tear, and make it more user-friendly, running 24/7. And the challenges we were facing for this is we had existing hardware and we had some firewalls, so we had problems with the connection. And this meant we had to use on-premise hardware and couldn't connect it to the cloud. And then we used Azure Arc, a Kubernetes cluster, and all the tools I explained today, and could manage this. And here you can see this was our test center. So for me personally, this was one of the highlights because as a software developer, we click through our software and nothing is happening. But there I could click a button and suddenly something started to move, a door opened, and I felt like a little kid just with big toys, and it was great. And
Wolfgang, thank you very much. I think we may need to skip the second project story, but the first one was exactly what everyone dreams of, having a project where they can see the effect from all of the code.
Yes.
Otherwise, it's just like you're constantly working and
I just have two
starts
slides
all over.
left about my opinion of the hybrid cloud, and then we can go to the questions in case we have some.
We don't. We have 10 seconds left from the slot.
Oh, okay. So the conclusion is hybrid cloud is a really powerful tool. It's great, but it's also complicated. So you have to have the skills and plan it before you can use it. And with this,
Okay,
here on the
and
QR code, you can find the slides. And if you have any questions, just contact me on one of the social media platforms.
perfect. This was very informative. Thank you very much, Wolfgang, and hopefully this will bring wisdom and more efficiency to a lot of other engineers' lives. So we're going into a 10-minute break. See you again in a bit. Bye.
Bye.